Assalamu alaikum warahmatullahi wabarakatuh. Dear students, we are going to learn about flotation in this chapter. Right? Before we move to the flotation, right? I'm saying something to you. Think about this. Now, a liquid is here. I am going to take this box inside the liquid, right? Think about the stages that I am covering. The first stage, the second stage, and the third stage. When I dip this, sink this inside the liquid. Now, if this is in this stage, right? This part is inside the liquid, right? Before this come inside the liquid, this part has been filled up with the liquid, right? After taking this inside, right? If this want to replace this place, right? Then the liquid which were there should be displaced. Correct or wrong? It should be displaced. The displaced liquid, if you consider the displaced liquid, right, that displaced liquid volume is going to be very similar to the volume which is sinked or the sink part of the block, right? If you consider the sink part of the block, there should be a volume. That volume has been replaced the water, then the water which were there should be displaced. That's why if you keep an object inside the liquid, right? If you try to take an object inside a liquid, right? You may see that the liquid level will rise up because the part which is replacing, right, of the liquid has been displaced. The displaced part is going to rise up the level, right? If you go more deeper, right, then the volume displaced is going to be equal to the part which is sinked inside, right? No need to think about this part because it's not inside the liquid. Therefore, no need to displace liquid for the part which is there in the air, right? If you completely take inside, the displaced is equal to the replaced. The replaced part is the volume of the object. The displaced, the volume of the liquid is going to be equal to the volume of the object, right? Take this knowledge and come to the flotation, right? The next thing, another thing I am going to say you. Now, when you take an object inside the liquid, right, by pushing something right inside, not an object, pushing something inside, right? When you push something inside or if you take something inside, right, there will be a difficultness due to this liquid which is working against to your push, right? When you take it from the air, when you take in along the air, right, you are not going to feel that. Once you take it inside the liquid, right, you are going to feel something is opposing upwards, right? Do it and see, right? Something is pushing up, right? And you are working against that push, right? Then only you can take the object inside, right? That is a type of force which is exerted upwards. That force is known as upthrust. Then there is a force which is known as upthrust, right? Due to the upthrust, when we consider the value of upthrust, how much is the value of the upthrust. What is the value of the upthrust? Right? That is very similar to, right? You know the displaced liquid. You know the displaced liquid, right? If you consider the displaced liquid is there, right? If you consider the mg or the weight of the displaced liquid, that weight is normally equal to the upthrust. How you are measuring the upthrust? If you want to really measure the upthrust, how much of upthrust has been applied now, right? That is going to be equal to, the upthrust is going to be equal to, right, the weight of the liquid displaced, right? If you measure that, then that is going to be equal to the value of upthrust. Now think about the situation that we discussed earlier. In this situation and this situation, right? Here also you have an upthrust, here also you have an upthrust. But since the upthrusts are not equal, why? I said to you the upthrust is equal to displaced liquid weight, right? Here the displaced liquid is not equal to the displaced liquid here. Here you have more displaced liquid, and that at this situation, the upthrust is going to be equal to the liquid which has been displaced by this situation, right? The weight of the liquid, right? Then the weight of the liquid in this situation, this is first situation, the second situation is going to be more. Then the upthrust due to the first situation and the second situation, in the second situation is going to be more. In this third situation, the volume is going to be what displaced. Therefore, the displaced liquid volume, the liquid weight W3 is going to be equal to the upthrust, right? Therefore, at this point the upthrust is going to be different, right? Now, if you take this object here and here inside the liquid, no problem. The upthrusts are going to be equal because no more liquid is going to be displaced by this object, right? By taking this object here or here, right? No more liquid is going to be displaced. Therefore, the weight of the liquid is going to be same, right? That is equal to the upthrust. Then you know what is the upthrust, how the upthrust is working, right? And the upthrust, the value of the upthrust, how we can measure it, right? Two things have been explained to you, right? Now, this is the very easy thing that you should understand, right? Very easy thing. Now think about an object which is floating. Think about an object which is floating, right? Floating mean what? This is not moving, is it? Right? It's not moving. Now, an object without a movement, right? With two forces, the one, the weight of the object, the second one is the upthrust force, right? The forces which is existing in this on this object is, first is the weight itself, and second one is upthrust, right? Now you are saying, right, this is floating. Floating means not moving inside or outside. It's there in the same place. It may be vibrate. No, I am not talking about the vibration. We'll say that the object is stationary. It's there, right? It's immobile, right? The object is stationary. At that point, the weight is going to be downwards, upthrust is going to be upwards, right? You know, if the object is in the rest, then that is in the equilibrium. If it is in the equilibrium, right, it's not moving either in this side or on this side, right? Therefore, this should be equal to this. Then upthrust is going to be equal to the weight of the object. Upthrust is going to be equal to the weight of the object, right? Then the flotation is always going to be takes place, right? But since no, another idea, since this u is equal to the weight of the liquid displaced. What is the weight of the liquid displaced? mass of the liquid displaced into gravitational acceleration. What is the mass of the liquid displaced? This is the mass of the liquid displaced. Now you know the mass of the liquid displaced in terms of you can get a value in terms of density and volume, because the density is equal to volume, the mass over volume. Therefore the mass is equal to density into volume, right? If we can say the density of the liquid is rho, right, the volume that has been displaced is V, right, then we can say the V into rho of the liquid is going to be equal to the mass of the liquid displaced. What is this V? That is the displaced liquid volume. Displaced liquid volume into rho is going to be equal into G is going to be equal to the weight of the liquid. Therefore, this upthrust is going to be equal to, we can say an equation for upthrust. Upthrust is going to be equal to the volume. What is this volume? Displaced liquid volume. Or what is this rho? The liquid density into G. These two are the mass of the liquid displaced into G is going to be the weight of the liquid displaced. That is going to be equal to the upthrust. Now, this is the upthrust. Now, we can say using this phenomena, this idea, right? If an object want to, this is what this is saying to you. The object is floating. Because of the flotation, we can say the upthrust is equal to weight, right? In vice versa, right? In other terms, we can say if the upthrust is equal to weight, right? If the upthrust is equal to weight, then the object can float. If the object is floating, upthrust is equal to weight. That is the term that we know, right? If you take the vice versa, if the upthrust is equal to weight, then the object can float, right? What is upthrust mean? Liquid, displaced liquid weight, right? If then in another term we can say, if the displaced liquid weight is equal to the weight of the object, right? Displaced liquid weight is equal to the weight of the object, right? Then the object can float, because the displaced liquid weight is going to be equal to the upthrust, right? If the upthrust and weight are equal, then it can float, right? That idea I am saying in the words, right? If an object has an ability to displace liquid which is the equal to the weight of the object, right, then the object can float, right? This is the flotation, right? In this flotation we are finding this amount of knowledge, right? There are some activities given in your book, activity 15.3 and 15.4. Go through the activity, then you can understand more. This is the basic idea that you should gain. Okay, then the hydrometer that we are using to, that is the meter that we are using to measure the density, right? That hydrometer is working due to the flotation, because the hydrometer which is kept inside the liquid, right, is going to float, right? Due to that flotation, right, the level of the flotation, we can find the density of the liquid, right? We can find the density of the liquid, right, due to the height. That calibration is there, right? I'm not going to explain you very much on this, right, because it's not that much in your syllabus, right? The hydrometer is used to find the density, the first knowledge. The second thing you should know is the hydrometer has been made up using the theory of flotation, right? Using that only we are finding the density. You can gain more knowledge, no problem. Go through YouTube or something. If you want, I'll put some videos for the hydrometer as well, right? Inshallah, go through it, and you can personally gain knowledge about the hydrometer. Then I have been completed the flotation. From this video, from from this video, I've been completed the 15th chapter, right, which is very important chapter, right, and inshallah in next video we can go to chapter 18, which is work, energy, power, very small chapter. Inshallah, I think in one video I can complete it, inshallah. Then we can start current electricity, 19th chapter. Okay, barakallahu fikum, jazakumullah khair.